looking at questions in optical phenomenon of matter. This is really a all or nothing situation. And I think most of us should be able to get all our points here, or all our marks here. So let's quickly have a look at what we're going to do. Right, first of all, I'm referring once again to the examinable content document. Mine looks a little bit different because I scribble in mine, and so should you be scribbling in yours and making all the important notes, because this is what you need to know at the end of the year. Right, first of all, if we have a look in our content document, what it says we need to look at the photoelectric effect. And immediately when they tell us to look at the photoelectric effect, people, very important, we have a definition starting off there as well. The definition says it is the process whereby electrons are ejected from a metal surface when light of a suitable frequency is incident on that surface. Right, so that definition, photoelectric effect, we must know immediately. Right, we need to know the importance of the photoelectric effect, and remember it has to do with the particle nature of matter, right? Then we need to be able to define the threshold frequency, so there we have another definition. Can you see why I say this is all or nothing? You just have to study really hard, yeah? Your threshold frequency, and please make sure that you know that your threshold frequency looks like that, right? It is described as the minimum frequency of light which is needed to emit electrons from a certain metal surface. Okay, right. So we must know threshold frequency, and then lo and behold, we have another definition there, and my next definition is the work function. Right, the work function. Once again, please also make sure that you know that this is how we show the work function. It is the minimum energy. Now let's quickly look at the difference between threshold frequency and work function. Threshold frequency is the minimum frequency. Work function is the minimum energy that an electron needs in metals to be emitted. So the frequency has to do with the minimum frequency, and the work function has to do with the minimum amount of energy. And just remember, people, to do work you need energy. So that is the minimum energy. Right. Then very important, we need to be able to perform these calculations. And once again, that is the work function. Okay? Or it is Planck's constant times by the threshold frequency. Okay, we're going to get back to the data sheet in a little while, and then we need to explain the effect of intensity and frequency. Okay, and it's quite important that you know this difference. Okay, the emission and absorption spectra, I find that this is really something difficult for us to understand. So it is once again important that you learn your definitions. Okay. Explain the formation of the atomic spectra by referring to energy transition. Okay, so the important thing is, yeah, when we have a change of energy, we have a difference in the emissions, okay, in the emission and the absorption spectra. We're going to look at that now. Explain the difference between the atomic absorption spectra and emission spectra. Right, and now what is the difference? Right. Absorption spectrum is formed when certain frequency of the electromagnetic radiation that passes through the medium. Okay. In other words, it is formed for when a cold gas is absorbed. Right. So in other words, there is an absorption here. Okay. And the emission spectrum is formed when certain frequency of electromagnetic radiation is emitted due to the electrons making a transition from a higher to a lower energy state. Right. Now remember, I don't know if you can remember this, but when we looked at the atomic structure of certain elements on the periodic table, we often said that they wanted to be in a happy place. Okay, and then they would give off electrons, okay? So what happens when they give off electrons is they move to a lower energy state. And then we refer to this as the emission spectra. Okay. You need to know the difference between the two of them, and you need to know the definitions between the two of them. That is basically all that they're going to query you on, okay? Or they're going to question you on. So if you can remember that the absorption spectrum has to do with certain frequencies of radiation that pass through a medium, okay? Like, for example, a cold gas. Whereas the emission spectrum has to do with the frequencies as well, and yeah, it has to do with the emission of the atom's electrons. In other words, moving to a lower energy state. And that is basically, if you learn that, people, now we need to look at the questions. Okay, first, before we look at the questions, where do we find this information on our data sheet? Important for you to know, it is possible that they can give you velocity and wavelength. Then you need to work out the frequency, and over here as well, they could give you the period. So you can be asked to make use of these, although these could more than likely be used with the Doppler effect, but you need to know them, right? Then we have E is equal to HF, okay, and E is equal to HC over lambda. Okay. Now, please remember, once again, we're busy with the speed of light here. Let's just go back to our constants. Okay, there's H, Planck's constant, which is given as 6,63 times 10 to the negative 34 joules second. Okay, and then C is when we are busy with the speed of light in a vacuum. Okay, now very often you have to make use of, they ask you to calculate E, and they only give you wavelength, and then you think, but you don't have enough information. Remember, you are given Planck's constant and C. Okay? And then over here, we have the different forms of our formula, where E is equal to my work function plus my kinetic energy. And now just quickly have a look here. I just want to show you. Here is work function. Okay? So H times by my threshold frequency is the same as my work function, okay? And this is the same as that, okay? A lot of us prefer to break down our formulas. So that's why I just want to show you that. Right, now, let us see if we can answer some questions and go into some questions regarding this work. Right, I have a question. Once again, these questions come from a document that was compiled that has various exam questions in for you people. You should have it. If you don't have it, please ask your teachers for it. It is also on as a PDF document on the system. Right. In an experiment on the photoelectric effect, light is incident on a surface of a metal and electrons are ejected. What does the photoelectric effect indicate about the nature of light? And remember, we said to you that it's important here that this means to us that light has a particle nature. It indicates the particle nature of light. All right. Right. The intensity of the light is increased. Now, quickly, let us stop here. This was one of the things that was in the science, as I call it, the science Bible. Right. They said to us we need to know the difference between what happens if frequency is changed and frequency and intensity. Right. People, frequency means the hertz is changed. And if we change the frequency, we are changing the color of the light. Okay. If we change the intensity, we are keeping the frequency the same, but we are giving more of exactly the same color of light. Okay? So that you need to remember. Let us look at how that relates in our formula. Right. In our formula, it means that the frequency remains the same. Okay? Only the intensity changes. So people, my kinetic energy can't change here. Right, so let's have a look at it here. It says here the intensity of light is increased. Will the maximum speed of the light, speed of the ejected electrons, increase, decrease, or remain the same? The intensity of light is increased. That means I am only getting more light of the same frequency. And remember, I've already indicated to you that the maximum speed will not change. Okay. So they say here, will it increase, decrease, or remain the same? So you're going to tell me it is going to remain the same because I told you the maximum speed can't change. Because the maximum speed is only going to change when I change the frequency. Okay. So that's the first part of your answer. Now you've got to give the reason. Okay. So for your reason, you are going to say, for light of the same frequency, the energy of the photons will be the same. Right, okay. In other words, your kinetic energy is not going to be more. You can have more photons possibly, but you won't have more energy. Okay. And it's important that you state for light of the same frequency because it indicated that you understood that when they changed the intensity, your frequency remained the same. Okay, you got that? Let's just quickly swing this question around. What would happen if you increased the frequency? Right. Then you would have said it increased. Okay? So you increased the frequency of the light. Because then it would increase. Because at a higher frequency, it would mean more photons are emitted, which means, not more photons, photons with more energy are being emitted. Lower frequency, less. Right. Here we have a table below which shows us the values of the threshold wavelengths. And very important, they've indicated to us the wavelengths and for different metals. So the wavelengths for silver, calcium, and sodium. In an experiment using one of the metals above, the maximum speed of the ejected electrons was recorded to be 4,76 times 10 to the 5th meters per second. And the wavelength of the light was that. And now they say to me, identify the metal used in the experiment. Okay. So I think the first thing we are going to have to look at is what formula will we use. Okay. And basically, we are going to use that formula. We're going to change it slightly. But let us write down that formula exactly the way it is, and then we will make it bigger or embroider it from there. So we have E is equal to my work function plus my maximum kinetic energy. Okay. Now, to get E, okay, how am I going to do that? I can use HF, but I've got no frequencies. I have only got wavelengths. Let's just double check. Yes, I only have wavelength because there I have a wavelength. So in other words, instead of using E, I'm going to use the formula HC over lambda. Okay? You agree with me there? And then for my work function, I'm also going to use HC over lambda. But this lambda is going to be for my threshold. Okay, so it's quite important that you remember that. Plus my maximum kinetic energy. And I wonder if you can remember that formula. If you can't, oh well, they've given it to us here. I was just going to say go back to energy. But there it is. So my maximum kinetic energy is half mv squared. Okay. So all I do now is I go and I substitute in. So the first thing I need to do is go back to my constants. I need to go back to my constants, and it becomes 3 times 10 to the 8th. Oops, I've put the speed of light first. Just take note of that, please. And then times by Planck's constant times 10 to the negative 34 over the wavelength. I'll go back to that now. And once again, I have here Planck's constant, 6,63 times 10 to the negative 34, times by 3 times 10 to the 8th, over my threshold wavelength, plus half of my mass, right? There's my mass of my electron, half of my mass, which is 9,11 times 10 to the negative 31 over my velocity. Right, now let's go back to our question at least. And our question says, let's just check, our wavelength is 420 nanometers. And remember, we cannot work in nanometers, so it becomes 420 times 10 to the negative 9. Because remember, nanometers is to the negative 9. And my maximum speed, so I need to substitute this in here. I hope I'm going to have enough space. 4,76 times 10 to the 5th. And please, please, please do not forget the squared. Right, that is something we very often forget, so please remember that. Okay, and now, ladies and gentlemen, your biggest problem now is maths. Your biggest problem now is your maths. Okay, so you solve for this, and if you solve correctly, I'm not going to spend too much time on the solution of this, but if you solve correctly, you should get that it is 5,37 times 10 to the negative 7 meters. Okay? So that should be your answer. And now, oh, that's not your final answer, because your final answer was identify the metal. Okay? So now you've got to look at your answer and where it fits in, and it best fits in at sodium. Then you must interpret your answer and say, therefore, sodium is the metal. Right. I just want to stop here in particular about the mark allocation, because for some or other reason you get yourselves into a complete state because of the maths here. And I actually just want to show you that the maths here is not the most important thing. Right, you would have got a mark for your formula, okay? Then you would have got a mark for this. You would have got a mark for that. And you would have got a mark for this, okay? Now, can you see that this question was out of 5 marks? And then you would have got your final mark for saying that sodium was the metal. Okay. And I just want to show you here, it's 1, 2, 3, 4, 5 marks. If you really, really struggled with the maths, you would have lost 1 mark. Yes, I know all of us want to get level 7, so we can't even lose 1 mark. But I'm just trying to show you, please don't panic. Please don't panic. Right. Just make sure that you do the correct things. And quite honestly, this is very easy. Because all you did here is use your data sheet and substitute it in. Okay? Right. Now let's go and look at the next question. The next question here says to you, the simplified energy diagram showing a possible electron transitions in an atom as shown below. Using the letters P, Q, R, and S, identify the lines correctly that show the transition of the giving off an emission spectrum. Right, so we're busy with an emission spectrum, and I wonder if you can remember what we said, an emission spectrum. I want to show it to you here so that you can see how to apply it. What was an emission spectrum? Emission spectrum was energy certain frequencies of electromagnetic radiation is emitted due to the atom's electrons making a transition from a high energy state to a low energy state. Now let's go and apply that in our question. What has happened over here? Can you see in this question, they've gone up an energy level. So it's gone from E1, energy level 1 to energy level 2, and from energy level 2 to energy level 3. Okay, right. We're busy with the emission spectrum, so it moves to a lower energy level. So in other words, I would then use the letters Q and S. And now they ask me for the reason for my answer, and then you give them the definition of the emission spectrum. Then you would have given that definition that we just looked at. Right, this was one question. I'm going to look at another question that was a little bit more tricky. I wanted to bring in this question in particular because of the fact that most of us, when we see graphs, we get really nervous. Why? I'm not quite sure. But let's have a look. Right, so this is also still busy with the photoelectric effect. A learner is investigating the photoelectric effect of two different metals, silver and sodium, using light of different frequencies. The maximum kinetic energy of the emitted photoelectrons is plotted against the frequency of the light of each of the metals shown. Define the term threshold frequency. Now, once again, that is a straightforward definition that you should know, and you should know that it is the minimum frequency. Matrix, another thing, when you're busy doing papers and they ask you to define threshold frequency, don't just recite it. Actually write the definition down. So write it down so that you can get used to it, and that's the way we learn. Right, so it is the minimum frequency needed to emit electrons from the surface of a metal. And please, once again, please make very sure that you remember the words, the minimum frequency. Okay? Right. Which metal, sodium or silver, has the largest work function? And explain your answer. Okay. Now, first of all, for you to be able to do that, you need to know what the work function is. And if you have a look at this, this is your work function. Right. Your work function is H times by your threshold frequency. Now, can you see that one of these, this one has a larger threshold frequency? Because look at 5.94 times 10 to the 14th hertz, sodium started emitting electrons. Okay, so sodium's work function would have been W times by HF. Okay, this would have also been W times by HF. Okay, H is the same in both of them. This one's frequency is higher. Therefore, silver will have the higher work function. Okay, which metal, sodium or silver, will have the highest work function? So you would have to tell me silver, and then you could have explained it to me in the way I did, or you could have said that silver has a larger threshold frequency. Right, so silver has a larger threshold frequency. You could have made use of that, where you would have said that your work function is directly proportional to your threshold frequency. Okay, like I explained there. Right, now they say, if the light, and yeah, you can see exactly how the questions are just repeated, people, so you've just got to practice. Oh, Name the physical constant represented in the slopes of the graphs. Remember, we've just said W is directly proportional to that. So the only one that is left here is Planck's constant. Planck's constant, okay? That is the physical constant represented there. Now, if light of the same frequency is shone on each of the metals, in which metal will the ejected photoelectrons have a larger maximum kinetic energy? Right. People, if the threshold frequency is lower here, then this one will have more energy. Right, because not as much energy is needed for it to be ejected. So a lot of the energy is going to go into kinetic energy. Okay, so my answer here is going to be silver. And your trick here was light of the same frequency. Okay, light of the same frequency. If they asked for a reason here, you would have, oops, no, not silver. Sorry, sodium. If they'd asked you for a reason here, you would have said sodium has the lower threshold frequency. Look at my formula. Sodium has the largest threshold frequency, the lower threshold frequency, which means it will have a lower work function, which means more energy will be emitted. Okay. Right, next question. In a different photoelectric experiment, blue light obtained from a light bulb is shone onto a metal plate and electrons are released. The wavelength of the blue light is that. The bulb is rated at that megawatt. Oh, and the bulb is only 5% efficient. Now I remember why I asked this question. Right, because this is quite a tough question. So before we can actually do anything else here, we are going to have to work out how much energy is actually emitted. Okay, so what we have to go and work out here is we have to work out 5% of 60 milliwatt. Okay, right. So what is going to, and I used the words megawatt just now, it's milliwatt, please. Megawatt would have looked like that. Okay. So I'm going to say 5% of 60 milliwatt. Okay. So it's going to be 5% or 5 over 100 times by 60 times 10 to the negative 3. Remember, that is milli, so it's negative 3. Okay, I'll work that out, and that should give me 3 times 10 to the negative 3 joules per second. Okay. Right. Now, what you need to remember of this, people, is that that is the only amount of energy that is how efficient the bulb is. So only X amount of that energy is actually being used for that. Right. So that is the first thing we had to do. Now, the next thing that we have to work out here is calculate the number of photons that will be incident on the metal plate per second. Okay. So to calculate my number of photons, I'm going to use my formula E is equal to HF. But I'm not going to be able to use that formula because, can you remember, I have been given lambda. I've not been given HF. So I'm rather going to use the formula HC over lambda. Right. So my energy emitted by my photons, E, is going to be equal to HC over lambda. Back to my constant table. H is, there we have it, 6,63 times 10 to the negative 34. 6,63 times 10 to the negative 34 times by light, which is 3 times 10 to the 8th. 3 times 10 to the 8th. Okay. Please, another thing, matrix. I know a lot of you learn really hard and a lot of you remember these things. Rather go to your constant table and just make sure that you write down the correct constants. It's really sad if you see the person knows everything and they go and use the wrong constants. Okay. Right, so now I've got to go back because I've got to go to lambda. And they were nice in this question. Can you see they gave it to me all in one in meters already. So it's going to give me 470 times 10 to the negative 9. Okay. So now I'm going to work out how many photons are emitted. Right. Okay. So we have and I get 4,32, 23, check, 4,23. So that gives me, times 10 to the negative 19, don't forget that. So that gives me 4,23 times 10 to the negative 19. Okay, so that is how many would have been emitted. Let's just check our question. Calculate the number of photons that will be emitted, will be incident on the metal plate, assuming that the light, okay. But now remember, people, that would be my number of photons, okay, or my energy in that. So now I've still got to go back, because now I'm busy with the second thing, hey. So now I've got to go and I've got to say, right, my total number of photons per second is going to be equal to 3 times 10 to the negative 3. Remember, that's joules. And remember, that was joules per second. Okay. Over 4,23 times 10 to the negative 19 joules. Okay. So I go and I work that out, and I should then get an answer of 7,09 times 10 to the 15. Okay. This was a tricky one. This was really a tricky one. I think the majority of us could work out the 5%. And for the 5%, we would have got 1 mark. Right, so I just want to show you mark allocation here again. Right, so we would have got 1 mark for that. We would have got 1 mark for our formula, 1 mark for the substitutions of our formula, and then we would have got 1 mark here and 1 mark there. Okay. So this was a tricky one. If you couldn't do the last section, you more than likely would have lost 2 marks. For level 7 people, you've got to go and make sure that you can understand these and that you can do those last 2 marks. That is really, really important. Now they say to me, without any further calculation, write down the number of electrons. Oh, they're being difficult, yeah? They're not actually being difficult. Remember your number of photons. 1 electron emits 1 photon. So now they want to know from you your number of electrons. And now you have a choice. You can either go and say the same as 7.2.1, because you know that every electron emits a photon, or you could have gone and said 7,09 times 10 to the 15. If you'd got this answer wrong and you'd written the wrong answer there, you still would have got your mark. Okay. So that is basically what the photoelectric effect is about. The most important thing about the photoelectric effect, people, is knowing your definitions and then knowing how your definitions fit in here. Okay. And to know that my work function is, I can use this to calculate my work function, and I use HF to calculate that E. Okay. And if I don't use HF, I can use E is equal to HC over lambda, or E is equal to HC over the threshold wavelength. Okay. And then where my maximum kinetic energy is half mv squared. The other important thing is also to remember the difference between frequency and intensity. Right, so that is the few things we must remember here. With a photoelectric effect, a lot of it really has to do with calculations, people. So just make sure you write down your formulas properly, that you substitute correctly into your formulas, your definitions, what is your photoelectric effect, your threshold frequency and your work function, and then your emission spectrum, which is when the atoms make a transition from a higher energy to a lower energy state, and your absorption spectrum, where we have a medium. There's a medium through which it passes. Okay, right, that is all about the photoelectric effect. Get in there, study hard, do lots of exercises. Good luck. Bye.